Hey everyone, notes 5.4 are on problems with slope, length, and midpoint. So we're going to take everything that we've learned so far this unit, how to find midpoint, how to find lengths of line segments, medians, perpendicular bisectors, altitudes, all that kind of stuff, and we're going to solve problems that have all of these different things in them. So in example number 1, it says to determine the radius of a circle with endpoints of a diameter mn. So we are given these 2 points right here. So I'm going to graph out m and n. So m is at -3, -4, and n is at 5, 2. Okay, and I want to find the radius of the circle that has these endpoints for the diameter. So that means that my circle is going to look as follows. This is what my circle is going to look like. So I want to know the radius of this circle. So to find the radius of the circle, I need to know what the center of my circle is going to be first. So to find the center, I have to find the midpoint of segment MN. Okay, so to find the midpoint, I would just do x1 plus x2 over 2, and then y1 plus y2 over 2. Okay, so let's go ahead and calculate this. So the midpoint of MN would be, this is x1, this is x2, this is y1, this is y2. So it would be -3 plus 5 over 2, and then -4 plus 2 over 2. So the midpoint of MN would be 2 over 2, -2 over 2, which is 1, -1. Which, when I look at this midpoint right here, I can definitely see that it is going to be at 1, -1. I'm going to call this a different letter just because I already have an M here. So I'll just call this A, and A is my midpoint. Now to find the radius, I want to know how big my radius is. I need to actually calculate how big it is from A to N. Or alternatively, I could also calculate how big it is from A to M. But because this is in the center, I would always get the same answer. Okay, so I'm just going to use from A to N. It's your choice. So we know that A is 1, -1, and we know that N is 5, 2. So I'm going to use the formula for midpoint right here. So L equals the square root of x2 minus x1 squared. And I'm sorry, I said I'll use the formula for midpoint, but I meant the formula for distance, the distance formula. Okay. So right here, my x1 is 1, my y1 is -1, my x2 is 5, my y2 is 2. So I'm just going to fill in all of that information. So x2 is 5, x1 is 1, 5 minus 1 squared, plus y2 is 2, and then I'm going to subtract a -1, and I'm going to square that. So this ends up becoming 4 squared plus 3 squared, which is the square root of 16, plus 9, which is the square root of 25, which is 5. So we can say, therefore, the radius of the circle is 5. And that's my answer for this question right here. But there's another way that we could have done this. I don't want you to actually do it, but I just want you to just write down what is a possible method. What is another method that we could have done in order to figure out the length of the radius, in addition to finding the midpoint and finding the length of the radius from A to N? What's another possible way to do it? Don't actually do it, just describe what we could possibly do. Let me give you an example to help you kind of understand this a little bit better. So to find this length right here, step A says to find the slope of line L. You're going to need to go back and forth between pages 12 and 13. So I need to find the slope of line L. So let's actually draw a picture of everything that's given to us. So this is like point A. So I'm going to graph out point A. That is right here. And then this right here is the equation of the line that I am given. So y equals 2x plus 6. So my y-intercept is 6 and my slope is 2 over 1. So I would go up 2 over 1, but I don't have the space to do that. So instead, I'm going to go down 2 and to the left 1, down 2 and to the left 1. And I would just keep going until I get my line. So for this right here, I'm actually going to make sure that I draw this with a ruler or a straight edge to be 100% sure that I have have the most accurate line that I could possibly have. So this is the line that I'm going to draw right here. And the shortest distance from this point A to this line is going to be this perpendicular right here. So I want to know what the length of this line is, but I need to find my point of intersection, which we're going to call point B. In order to be able to find this point of intersection, I need the equation of this line. Okay, so I need the equation of this perpendicular line. So I need to find out what M perpendicular is going to be and B perpendicular. So what is the M and the B of this perpendicular line right here? Or I could just say right here, so this is line 1, and then this right here is line 2. So this is the M and the B of line 2. So let's go ahead and see where we can get that information from. Because L1 and L2 are perpendicular to each other, I can use the slope of L1 to find the slope of L2. And so since the slope of L1 is 2, then we can say that the slope of L2 is going to be -1/2. It's the negative reciprocal. So I know here that this is going to be the negative reciprocal. Cool. But I still have to find B perpendicular. And so in order to find the equation of this line right here, I need to find what B is. So I'm going to use point A and solve for B. Okay, so this right here, let's look back at what we have here. Step A was to find the slope of line L. So this is what we did here. This was the slope of line L1. Step B was to find the perpendicular slope right here. Okay, and then step C is to use M perpendicular in the coordinates of A to find the equation of AB, which is line 2. So let's go ahead and do step C now. So we're going to use y equals mx plus b. We know that m is -1/2, and we also know that it is going to pass through the point A. So we're going to sub in 0, -2. So I'm going to replace the y with -2 and the x with 0. And then -1/2 times 0 is just 0, so I get -2 equals b. So that means that b perpendicular is going to be -2. So we know now that the equation of this line is going to be y equals -1/2 x minus 2. Okay, which should be clear because this is literally our y-intercept right here. Okay, but here's the thing. I need to now find my point of intersection. So I need to figure out what this point is right here. So that's what step D is saying. So we know that this point of intersection is the intersection of line L1, which has an equation of y equals 2x plus 6, and line L2, which has an equation of y equals -1/2 x minus 2. And in order to be able to solve this, I can either use elimination or substitution in order to solve this. I'm going to use substitution because if you notice here, the y is already isolated. So I can replace this y in for this y. So I can say -1/2 x minus 2 instead of this y. I can take that out and replace it. And then I can just say equals 2x plus 6. Okay? And I'm sorry if you run out of room. I apologize. We have a lot of stuff to squeeze in right here. So let's go ahead and solve for x here. I have fractions. I do not like fractions, so I'm going to get rid of my fractions by multiplying everything through by a common denominator, which is 2. So I'm going to multiply this by 2, this by 2, this by 2, and this by 2. These 2's cancel, so I end up getting -1x. -2 times 2 is -4. 2x times 2 is 4x, and then 6 times 2 is 12. So then I'm just going to get my variables on one side, my constants on the other. So I'm going to move the -1x over, so I get 5x, and I'm going to move the 12 over right here, and I would get -16. Divide both sides by 5, so I would get -16 over 5, but because this is not an ugly decimal, I'm just going to divide it out, and I get -3.2. but I have to find the corresponding y value. So here, my corresponding y value would have to be, I can use either equation to figure that out. I can either use y equals 2x plus 6, or I could use y equals -1/2 x minus 2. I'd rather use y equals 2x plus 6 because I already have decimals. I don't want to have to deal with fractions and decimals, and the 2x plus 6 is just much simpler. So I'm going to say y equals 2 times, instead of x, I'm going to replace it with -3.2. Close my brackets, add the 6 to it, so I get -6.4 plus 6, which is -0.4. So this means that my point of intersection, again, I'm so sorry that there's not enough space here, but here our point of intersection is going to be -3.2, -0.4. If you need to do this on a separate sheet of paper, please go ahead and do so and then add it on. But here we can say our point of intersection is going to be -3.2, -0.4. So, and it's clear that that is really where it's going to be. That looks pretty accurate, that it's -3.2, -0.4. I have one last step. I want to find the distance between A and B now. So I want to find the length from A to B. So this is step E. I want to find the distance from A to B. So I'm going to find AB. And the way I would do that is by doing x2 minus x1 squared plus y2 minus y1 squared. So right here, I would plug in what my coordinates are. So we know that A, 0, -2, and we know that B is -3.2, -0.4. So I'm going to plug in that information. So here I get -3.2 minus 0 squared, and then right here, because this is x2, this is x1, this is y2, this is y1, so I'll do -0.4 minus 2 squared, and then I get AB is equal to the square root of -3.2 squared, because this is -3.2, plus this is -2.4 squared. I'm going to go ahead and calculate what these values are. So here I end up getting 10.24, and then 2.4 squared is 5.76. I'm going to go ahead and add those two values together. And I get the square root of 16. Oh, look at that. Turns out to be a nice, even, pretty number. So the length, the shortest distance, let's go back up here. The shortest distance between this line and this point is going to be 4. Okay? So the shortest distance from A to L1 is 4. All right, our last question says to consider the right triangle with vertices A, 5, 5, B, -3, -1, and C, 1, -3. So this is A, this is B, this is C. It tells us that this is a right triangle. So we know that this right here is a right triangle, and we want to show that the median from the right angle C of the triangle is half as long as hypotenuse AB. So in order for me to be able to do this, there are a few things that I need to know, and I just want you to know that we're going to need to have a lot of space to write inside of here as well. So I'm going to zoom in so I have enough space to fit everything in here. You're going to probably want to write super small or do stuff on a separate sheet of paper and staple it on. So for me to be able to do this, I need to know two things. I need to know how big AB is. I need to know how big this segment is. So that's one thing I need to know. But I also need to know the median, because I'm trying to show that the median is half as long as the hypotenuse. So the other piece of information I need to know is this right here, the median. But in order for me to find the median, I need to actually find this midpoint right here. So we need to find AB, and we need to also find CM. AB is easy to find because we already know what A and B are. So actually, let's do that first. Let's find AB. So to find AB, I'm using the point A, which is 5, 5, and the point B, which is -3, -1. So here, so to find this, I'm just going to write out the formula, x2 minus x1 squared plus y2 minus y1 squared. And I'm going to fill in that information into the formula. So here I'm going to do 5 minus -3, which is +3. And then here I'm going to do 5 minus -1, which is a +1. So here I get AB is equal to the square root of 8 squared plus 6 squared. 5 plus 3 is 8. 5 plus 1 is 6. So I get AB is equal to the square root of 64 plus 36. So I get the square root of 100, so I get 10. So I know that AB is 10. And that's going to be helpful to me as I go through and I do this. Okay, but now I need to find out what CM is. But I can't find out what CM is until I actually find out what the midpoint is. So the next thing I need to do is I need to find the midpoints of AB, which we already have the coordinates for A and B right here. Okay, so the formula for midpoint is going to be x1 plus x2 over 2, y1 plus y2 over 2. So we know that x1 is 5, x2 is -3, just like we knew that right here. So I'm going to label this as 5 plus -3 over 2. And then we also know that this would be 5 plus -1 over 2, because right here y1 and y2 are 5 and -1. Okay, so right here when I do this, I end up getting 2 over 2 and 4 over 2, which ends up being 1, 2. So if I graph this out right here, 1, 2 is definitely where our M is. So now I need to figure out what CM is. So to find out what CM is, I would use the point C, which is 1, -3, and I would use the point M, which is 1, 2, and I would calculate what that is using the distance formula. So let's go ahead and fill in the information that we know. So here, x2 is 1, x1 is 1. I'm going to square it. Here, y2 is 2, y1 is -3, so I'm adding 3 right here. So this ends up becoming 1 minus 1 is 0, so I get 0 squared. 2 plus 3 is 5, so I get 5 squared. So I end up getting the square root of 0 squared is 0, 5 squared is 25, so I end up getting the square root of 25, which is 5. So here we know that CM is 5. But to be completely honest, because the x values were the same, this ended up being a vertical segment. So I could have just counted 1, 2, 3, 4, 5. Okay, but only because it's vertical. We can only do this if it's vertical or horizontal. So now we can say, oh yeah, for sure, CM is half of AB. So we can say, therefore, the median is in fact half of the hypotenuse. And that's all we have to do for this question right here. And that's it for this video. Let me know if you have any questions, and I'll see you in class. Bye.